When we look at the recent anomaly at Launch Complex 36, it's vital to frame this not simply as a spectacular engineering failure, but as a massive macroeconomic bottleneck. The physical destruction at the pad has effectively paused the immediate momentum of the entire Western cislunar supply chain. While the corporate description points to a localized thermal shock, the raw reality on the ground was chaotic, turning night into daylight from nearly 12 miles away. This isn't an incident you resolve by just swapping out a few damaged parts. Over the next few minutes, we are going to trace how a single structural failure cascades far beyond the launch pad, rippling through maritime logistics, commercial markets, and national security manifests. To understand the gravity of the situation, look at the timing of this static fire. The test took place a mere week before the scheduled commercial orbital mission, meaning this vehicle wasn't an experimental prototype. It was a fully flight-ready asset tied to strict commercial contracts. While the chemistry relies on a highly energetic liquid methane and liquid oxygen reaction, the failure itself was purely mechanical. The structural breach of the engine manifold caused the massive first stage to buckle under pressure, mixing hundreds of tons of cryogenic propellant into an immediate, unconfined deflagration. The physical hardware is insured, but the true loss here is the instant vaporization of years of tightly synchronized scheduling and institutional momentum. The physical damage at the pad introduces some severe, long-term engineering bottlenecks. While steel infrastructure like the transporter reactor can be fabricated and replaced, the concrete launch mount and flame trench present a much more deceptive challenge. Extreme thermal shock fundamentally alters the internal crystalline matrix of reinforced concrete, meaning teams now face months of exhaustive ultrasonic testing to scan for invisible microfractures. If a single fissure is missed, the next launch could literally vibrate the pad apart. The one saving grace keeping the entire New Glenn program alive was the miraculous survival of the propellant farm. If those long lead storage tanks had gone up, we would be talking about a decade-long environmental and zoning rebuild. Modern reusable rocketry is as much a maritime operation as it is an aerospace one, and this event has completely severed Blue Origin's recovery pipeline. Behind the scenes, there is a massive financial bleed occurring. The highly specialized recovery vessel Jacqueline and its dedicated marine support crews are now entirely idled at port, burning through daily capital with zero incoming flight data to offset the cost. More importantly, high-cadence booster reuse relies heavily on rapid operational muscle memory. By freezing the very first step of the chain, the entire downstream loop for practicing booster retrieval, offloading, and rapid refurbishment has been put on ice. Right now, there is a massive psychological gap between corporate messaging and aerospace reality. While leadership is under immense pressure to project a rapid 6-month rebuild to stabilize partner relationships, historical benchmarks tell a very different story. Back in 2016, an identical pad explosion destroyed a Falcon 9 at neighboring LC-40. SpaceX is historically the most agile entity in modern aerospace, and even they required 15 months of non-stop reconstruction before hosting another flight. Given Blue Origin's historically methodical pace, a 15 to 24-month timeline is the realistic baseline, pushing a true return to flight deep into 2028. The commercial fallout from this pad freeze is immediate and severe. For Amazon's Project Kuiper, the loss of 48 satellites is overshadowed by a regulatory emergency. The FCC's July 2026 deadline is legally binding. If Amazon cannot launch nearly 1,300 more satellites immediately, they risk forfeiting their orbital spectrum licenses entirely. Meanwhile, AST SpaceMobile is trapped in a fairing bottleneck. Their Block 2 Bluebird satellites are structurally massive, spanning 2,400 square feet, and were custom engineered to fit exclusively inside New Glenn's unique diameter. They cannot pivot to small alternative rockets, leaving them entirely grounded and triggering intense market panic. This brings us to the most critical geopolitical pivot point of the investigation: shared propulsion risk. The modern defense infrastructure of the United States relies heavily on a single-engine architecture. Because United Launch Alliance's Vulcan rocket buys its BE-4 engines directly from Blue Origin, any systemic issue discovered during this post-explosion analysis has massive consequences. If the root cause is isolated to ground equipment, the broader market escapes. But if the investigation uncovers a fundamental design defect in the turbo machinery, Vulcan's entire military and intelligence manifest will be grounded instantly, freezing America's redundant path to space for national security payloads. NASA's Artemis lunar roadmap is structured like an incredibly fragile house of cards, and it just hit a major bottleneck. You cannot build, test, or trust a crude lunar lander like the Blue Moon Mark II without thoroughly validating its automated propulsion and cryogenic fluid systems on the Mark I cargo variant first. With New Glenn grounded, the immediate casualty is the Mark I flight delivering the Viper rover. Beyond the loss of short-term lunar science, missing that critical early terrain and water ice data directly degrades the safety profiles and landing site selections for the human crewed returns planned years down the line. NASA deliberately spent billions funding two independent human landing systems, SpaceX's Starship and Blue Origin's Blue Moon, specifically to build redundancy and avoid a single point of failure. With Blue Moon effectively sidelined by the damage at Launch Complex 36, that entire safety net has vanished. SpaceX now holds a temporary, absolute monopoly on America's return to the moon. Monopolies eliminate competitive pressure and compress timelines. If Starship encounters a systemic design roadblock of its own, the United States has zero backup options left, completely stalling Western lunar ambitions. To truly grasp the scale of this event, we have to look at the sheer disproportion of modern airspace technology. A microscopic structural defect within a metal engine manifold occurring in a fraction of a second ripples outward in a devastating chain reaction. It physically halts a multi-billion-dollar commercial satellite rollout, triggers a sharp sector-wide stock sell-off, threatens national security launch manifests, and ultimately introduces a multi-year delay into humanity's permanent footprint on another world. It proves that in the modern space economy, the smallest component can dictate global timelines. In conclusion, the loss of New Glen NG-4 is a brutal reminder that spaceflight remains profoundly unforgiving and highly centralized. The entire commercial space sector has scaled exponentially, yet its physical launch infrastructure is still tethered to dangerous single points of failure. True operational resilience doesn't just mean fixing a manifold or pouring new concrete at LC-36, it requires breaking our geographic dependence and bringing redundant secondary pads fully online. Determined until that happens, our grandest national and commercial ambitions remain incredibly fragile. Credit Infericiter means step by step, ferociously. But right now, the industry must take a calculated step backward to safely move forward. Thank you for watching. Please like and subscribe. It really makes a difference.